the components that we're going to use to run unit tests. So Karma is the executor. Okay, so when you go to the command line, you have two ways of executing Karma. One is directly by calling Karma start, which will start the browser. In this case, I'm starting Chrome, and it's executing all 26 tests. Okay, and if I want, I can go and change them, and the moment I save one of these tests or files, it will run all the tests again. It's now in a mode where it's continuously listening to changes, and whenever it finds one of the files change, it will run the tests again. And the other option is to run grunt Karma, and then grunt will run Karma in a one-time way. So it will launch the browser, see that all the tests pass, and close it. So with grunt, I haven't taught you exactly what grunt is, but grunt has a configuration file, gruntfile.js, and here is the part that actually configures Karma, and it tells it that the Karma configuration file is this, and we only want a single run. So we just want it to run, and then if it passes, that's it, close it. So now let's look at the Karma configuration. So karmaconf.js, and Karma has a pretty long config file, but the important thing is the files. These are the files that Karma is executing, and there are some things here for the AI tests that you don't need to do for this homework. So the important files to execute is the game logic, right? This is what you wrote, and the game logic tests, which is what you're gonna write. And these two actually depend on Angular to work correctly. So it's also important to include Angular. So these are the files executed. Then we are just showing progress, how many tests passed or failed, and we're also running test coverage. So the coverage, we want to check how many lines are actually covered in our unit tests, and we want to basically instrument this file. That means Istanbul is going to modify this JavaScript file and add like callbacks into Istanbul to check whether each line of code was actually executed or not. And this is where you configure the coverage tool, and we want to create a coverage directory, and we want to output HTML. So if you actually look in tictactoe, you see that there is a coverage directory, and if I look inside of it, I see that it created one for each type of browser. So, and if I look inside that browser, I can see it created an index.html with the result. And if I double click on that, so for example here, I go to coverage, the browser, and double click on index.html, it tells me that I got the 100% coverage, and I see that it instrumented only this file, the gamelogic.js, right? And I can see everything is green, so everything was covered. If you won't get to 100%, then you could see, oh, these lines are red, I didn't cover that, I need to write a unit test that will make sure that this is covered. Okay, so this is Karma, and now Jasmine is what the framework we use to write the unit tests. You will only need to understand three methods inside Jasmine. One is describe, which defines a group of tests. Okay, so in our case we have describe, and we call it in tictactoe because when a test fails, it will create like a sentence. So it will take, so this is an example of the group, and this is an example of one test. So if that test fails, it will tell me in tictactoe, placing X in 0, 0 from initial state is legal, and then it will say it failed. Okay, so it tells me it should be like a sentence. And so these are the two methods you need to know, describe and it. And the other one is expect to be. Okay, so, and that's everything I use from Jasmine. So expect gets some argument, and in this case it's going to be true or false, and we expect it to be this variable is okay, which is also true or false. You have other things you can do. You can do expect to equal, and then it does this deep equality. And if you click on this Jasmine link, you can see that Jasmine has a lot of other things it can do. So the basic thing is just describe it and then expect to be or expect equals. But you have a lot of other things. You can do expect not to be, or expect to match, and then it does a string matching, or expect to be undefined, or to be truthy or falsy, or if you have an array, whether it contains a certain string. Many things, but you don't need them. But if you want, you can go over and see everything that it has to offer. Similarly, you can go and read more about karma or karma coverage or Istanbul, but honestly, you don't need any of that. If you clone tictactoe, the only thing you need to know is to run grant karma or run karma directly, and that's it. So the last thing we need to do is to go over all the unit tests. So the first method is expect move. So I defined a couple of helper methods. Okay, these are not unit tests, these are just methods that I'm going to use in my tests. Okay, so this is a regular TypeScript code, nothing special. The only thing special is the three methods I showed you. Describe, it, and this expect blah 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 to be another variable. So everything else is regular code, regular functions and regular everything, nothing special. So the expect move will get all the things I care about in tic-tac-toe. Okay, so you remember that isMoveOK gets an object that has the turn index before the move, after the move, the state before the move, after the move, so on, right? But in tic-tac-toe, I only use the turn index before the move, the state before the move, and the actual move, right? Everything else I can put null, right? Because I don't use the number of players. I completely ignore it. If your game behaves differently depending on the number of players, for example, domino with 2 players or with 4 players is different, right? The move will be different. So if your game needs it, then you need to pass extra arguments for the number of players. But for tic-tac-toe, I just need these 3 parameters: the turn index, the state, and the move, and then whether I expect it to be okay or not. And to make it even simpler, I created 2 additional methods: expect move okay, which calls it with true, and expect illegal move, which calls it with false. Okay, so the isMove okay is either true or false. And now let's look at the first test that expects a move to be okay. And I want to test the easiest scenario, that from initial state, if I press on X here, okay, then that move is legal and it creates this move. So you remember in tic-tac-toe, a move has 3 operations. In this case, I'm setting the turn to turn index 1, right? Initially it was turn index 0, and now it's going to be turn index 1. Then I'm setting the board to be this, and I'm setting the delta to be that I clicked in row 0, column 0, right? So this is my move, a list of 3 operations. And my initial state is empty, okay? So this empty object. Now, this is a TypeScript type conversion, okay? So an I state needs to have a board and delta. But I don't pass here a board and delta because the initial state is completely empty, right? None of the keys is there. So everything is completely empty. So that's why I cast it to an I state that has board and delta. But these board and delta are going to be empty here. Okay, let's look at another test. Now I'm testing something more complicated, that from this state, I can put an O here. Okay, so now it's the turn of O, and I want to place an O in position 0, 1 here, okay? And I want to make sure that this is legal. Okay, so the move now, the turn is for player O, so the turn index is 1. The board has this value, delta has this value, okay, and this is the move. The move is placing O here in position 0, 1, right? And this test will make sure that this move is okay. So it will call expect move okay, right? A normal JavaScript execution, which will call expect move with true, which will call this game logic is move okay, then it's going to call your is move okay, pass it all these parameters, evaluate it, and at the end it should return true, and this assertion is going to pass. Now if this assertion is not, if for example is move okay return false because of some bug, then this assertion is going to fail and your unit test is going to fail, and it's going to show you like that false is not equal to true, and you will need to debug it and figure out what's wrong. So you could debug it either using the simple test.html that like you've done before, or you could just execute karma like this and then set breakpoints in the debugger, or you can use console.log and then you'll see it on the output. Okay, so next let's do one test where it's an illegal move. So for example, I want to make sure that if this is the initial state, O cannot select position 0, 0 because it's already taken, right? So it's a non-empty position. So that is an illegal move. So now I'm expecting an illegal move. So I'm expecting is move okay to return false, right? And this is going to protect me if my UI is buggy. And if my UI allows you to press here, and I want to make sure that the is move okay is going to protect us and is not going to allow you to select that move. Yeah. So, and then I want to make sure that you cannot do any moves after the game is over. So this is another expect illegal move. And now I have a couple of tests to check that a move is okay for a move that ends the game. Okay, so I have 3 different things to consider. One where the X win, one, sorry, it's here. One where the X win, one where the O win, and one where it's a tie. Okay, so for example here, if the X plays here, then the X wins. And notice that now the move, instead of set turn, it has end match, and I have the expected end match scores, right? So the X is going to win, so it's going to have 1, and the score of the O is going to be 0. In contrast, if the O wins, for example, if the O plays here, then this is going to be the board at the end, and the O won via diagonal. Then now the end match scores are 0 for the X and 1 for the O, in contrast to 1, 0. And finally, in case of a tie, then the end match scores are 0, 0, right? So the tie is the X moves here, nobody won, so the game ends in a tie. Both players got a score of 0. Then I have some tests to really check some crazy moves. For example, if the move is null, if the move is missing many things, right? If you're playing outside the board, like in row 3, column 0, like a lot of crazy stuff. And finally, the last one, it's a test for get possible moves. Okay, I'm calling here game logic get possible moves. You don't need to do it for this homework because you didn't need to implement get possible moves. So that's it. So now you know everything about Jasmine and Karma, and you know how to run it and how to check for coverage. You know about the homework, and that's it. Remember, next week there is also not a lesson, and next week you can listen to the recorded talk on artificial intelligence, and there are going to be office hours. I'm going to email you about it. See you in 2 weeks.